Ever stared at an equation like 3x plus 5y equals 1 and wondered how to list every whole number pair that satisfies it? Today we will turn that puzzle into a repeatable recipe by learning what a Diophantine equation is, when it has solutions, and how to find them all. A linear Diophantine equation has the form ax plus by equals c, where a, b, and c are fixed integers and we want integer pairs x, y. Solutions exist precisely when the greatest common divisor of a and b divides c. Written GCD of a, b divides c. Let's test 3x plus 5y equals 1. GCD of 3 and 5 is 1. And 1 divides 1, so solutions exist. To find one particular answer we run the extended Euclidean algorithm on 3 and 5. 5 equals 1 times 3 plus 2. 3 equals 1 times 2 plus 1. Then back substitute to express 1 as 2 times 3 minus 1 times 5. Reading the coefficients gives x naught equals 2 and y naught equals negative 1. So the pair 2, negative 1 works. Once we have that single ticket, the complete infinite family is x equals x naught plus b over g times t and y equals y naught minus a over g times t, where t is any integer. For our numbers that means x equals 2 plus 5t and y equals negative 1 minus 3t. Slide t through negative 2, negative 1, 0, 1, 2 and watch fresh integer pairs appear. Try a quick reality check. 7p minus 4q equals 3 models handing out candy packs, so each group gets a whole number of packs. GCD of 7 and 4 is 1, 1 divides 3, so solutions exist. Running the same algorithm gives p naught equals negative 1 and q naught equals negative 2. And the general answer is p equals negative 1 plus 4t. Q equals negative 2 plus 7t. Choose t equals 1 to get the positive solution 3, 5. To solve any linear Diophantine equation, first confirm that GCD of a and b divides c. Then use the extended Euclidean algorithm to grab one solution. And finally generate every integer pair with the parameter t. Keep this 3-step toolkit handy and you can tackle countless whole number problems waiting in math, coding, and everyday logistics. Generate your own educational videos for free at eduvids.vercel.app.